I gotta think about this a little bit. First thing, I want to take the sandpaper off. Well, I could leave it on, maybe. I want to try to do this as simple as possible so it's easy to repeat. For anyone that has a sander and wants to make a part tumbler without any special, a lot of work stuff to actually do it. I got it. I'm going to mount it like this. And then it will sit like this. And this thing will just shake. And I'll just have it hang from the ceiling with the lid on it. We just have to have it mount like this without blocking the air intake and inflow vents that would overheat the motor if they were blocked up. So I'm going to wrap some wire around here where my fingers are wrapping it. My thumb and forefinger. Wrap wire around it and then wrap wire around the bowl coming off that wire. So one loop around it of wire and then some wire bands to come around, and then we'll cinch it down real tight over the lid and it'll be done. And then we'll just hang it from the ceiling and it will go and we'll have a bunch of crushed ceramic, my grandma's old china. We'll break it all and put it in this bowl to fill up the bowl with abrasive material, drop our car parts in, and boom, they will get completely clean. It's going to work. All right, step one, wrap wire around the base. That looks pretty good. Step two, oh, we don't want it facing that way. That would sand a hole through the bottom. We want the sandpaper facing away from the bowl, like that. This is like 12 gauge home electrical wire I'm using here for this job. Okay, so this will go over this, and I want another one doing that from the other side. Okay. All right, so now we got it like that. Now I want one more. It needs to be coming up on the bowl from 3 directions. Cranking it down tight so they won't lose their orientation and slide around and all meet on one side. So they'll stay where I kept them. Okay. All right, I think we're in there, boys. I just got to get a lid next. Well, I can show you the principle, though, without the lid. We may not even need a lid, actually. I could just wrap some cling wrap over the top. It's just to block a little bit of dust, right? We don't need to put a lid. Look at that. They're one. They're mated. I don't want the bowl to slip out one side, so I'm gonna just put a little wire between these two, the biggest opening. That'll just make sure the bowl's. Let's test it. Okay, let's put one more wire over the next biggest pair, which is these two. We just don't want the bowl to fall out and dump stuff everywhere if we leave the room. Alright, I think that'll... Why is it going to fall apart? Where? How? There's no way. Where can the bowl come out? How would the bowl pop out of here? Where? The bowl would have to ball into a little ball to break out of this. It's got wire on every conceivable spot it could come out, right? Plus, when you fill up the bowl, it'll put pressure outward so the bowl can't cave in and crush. I think it'll work. We can hang it like this. Now it's just going to be... I think it's going to work, guys. All right, we got to break some china now. Let's go get the china. I'm going to cancel that. Looks like the perfect amount we did. Okay. Alright guys, so here's it with it dried off. It does look a little different. You can see it's got like a yellow little thin glaze of rust, and a lot of the rust just pretty much scratches off with your fingernail. It's just like scale. So this would come off with a cleaner and a scrub brush and some elbow grease. It's like just rubbing off. So it is decoupled from the metal to some extent. I want, okay, I don't think it was vibrating violently enough. The parts are supposed to be flowing like water over the tumbling media is supposed to be flowing like water over the parts and continue moving all around. Mine were just vibrating in place, meaning they weren't vibrating violently enough. So my idea now is to we're not transferring the energy in this enough. So basically, sander has two parts: the handle part and the bottom part, and they both can move freely. Well, if you make one part not able to move, then just one will move freely, and that one will have attached to the bowl, which will then be moving the full range. If they both can move freely, then the bowl is just going to be vibrating based on just getting knocked a little bit, but it's not going to be moving this far. So it's only vibrating very slightly rather than moving like that, enough to really get the parts all moving and get the tumbling media actually, flowing like water and scratching at the parts really thoroughly. So we were just getting micro vibrations, not the full range of vibrations. So we were losing a lot of it. So now the sander cannot move around, but the top part can. But we still want to pinch it down this way so it's down. But yeah, we just want to hold the bottom part down, so we'll use the C-clamp for that. But this should prevent the kinetic energy of the sander being wasted in air just kind of moving around. Didn't work. Dang it, I'm failing here, guys. I'm sorry. I think we made a fundamental design mistake when we didn't attach the bowl to the bottom portion right off the bat. I don't think you can make this sander with it attached to the handle. I don't think the handle produces enough vibration. I think you have to connect the bowl always to the sanding portion. So I'm going to start actually from the start. I thought the vibrations coming off this would be more than enough based on my teeth chattering when I used this belt sander. I did not anticipate that would not be enough vibration to actually cause the tumbling medium to travel throughout the bowl, going around the part, flowing like a fluid, which is necessary. You can't just have it moving in place. It has to actually move everywhere. It should be coming up the sides of the bowl, going back down. It should look like a blender when the food's coming up and then going down like a whirlpool. It should look like that. It cannot just be kind of vibrating in place. That's not enough vibration. It's not meant to be a ball mill. Ball mill is a tumbling mill. This is that which is a tumble finisher. This is supposed to be a vibratory finisher. A vibratory finisher operates off vibrations. A tumbler operates off of just like dumping everything, and they both have pros and cons. I wanted a tumbling. I mean, not a tumbling, a vibrating. I wanted to create a tumbler or a vibrator. Ball mills are just not what I want at this for this. Oh my gosh, we gotta start over. It's very annoying. But I guess I have to get used to the idea that sometimes you gotta do something twice if you don't do it right the first time. Normally I do everything right the first time, so I'm not used to this concept, but Alright guys, a lot of these wires are just breaking with time. Look at that. And so we're losing our grip because the wires will break. All this vibrating is so hard on the copper wire that the wires are just splitting. And then when they start breaking, they lose their grip. And then it's not pulled tight and it's not coupled to here very well. And so this is just rattling and the pan's just floating on top. So I'm now thinking of attaching it to here some other way. By the way, guys, it did remove a lot of material. It is working. It just stopped working when all the wires started snapping. I didn't really know what was wrong, and I just started realizing a lot of the wires broke. Once the wires strapping this thing to the pot broke, the pot was no longer strapped that well, and then it just the energy wasn't transferring anymore. This could be bolted to the bottom of the pot, right? Alright guys, got a wider and taller pot. I think we got everything we need right here where I sit now. This is probably what I should have done from the beginning, to be honest, but I was looking to take shortcuts, you know. I wanted to get it going quick. I thought this would take a lot of extra time, blah, blah, blah. I'm kind of glad I did what I did because I got to roll out some stuff and learn some stuff and experiment a lot. And see how important it is to have this thing bolted to the top. I mean, I kind of learned by trial and error all kinds of stuff. We're using this little center punch to put markings where we're going to drill our holes. Okay. Oh. Oh. Okay. That's okay. I think we're good. Woohoo! I think we're in, boys. Oh my gosh! What happened now? Alright, I know how to fix this. We gotta put nuts on the back. It decoupled again. The bolts on the back, after they go through the sander, are just spinning around. So they managed to somehow unlock themselves. This is upsetting though. I mean, so I have to use locking bolts, right? Locking nuts, I mean?
Alright guys, here's the result after the part tumbler. We probably could have put it in there for longer, but you can see it has removed a ton of the rust. This is very light surface rust. Uh, it's pretty darn clean. I mean, you can see metal through the rust. This is going to be very usable. I think it just needs like one more like 4-hour session of electrolysis, or what I'm going to opt for, which I think is just easier at the moment, is Naval jelly it one last time. So that's what I'm going to do. I'm going to naval jelly it. This is Loctite Naval Jelly Rust Dissolver. It dissolves rust from metal surfaces. It leaves behind a white powder, which is very paintable. And I might just paint this thing with high heat paint after putting this on. Just hit it with a spray paint made for 2000 degrees, like for painting engine blocks and stuff. Alright, well. I know. Use Q-tip to put it in the caliper pin holes. It'll get down there. Oh, come on. I'm going to stand up right now.